quotient rule tells us that if we have the square root of a fraction, such as a over b, we can take the square root of just the top number over the square root of the bottom number, and treat those square roots separately. We can also use this property in reverse if convenient, and if we've got square roots on top and bottom, we can rewrite them as a square root over the entire fraction. Often, it is helpful to reduce the fraction first, and then reduce the radicals. Let's take a look at some examples where we reduce these expressions. Here, we've got two square roots. However, because we've got the same square root in the numerator and denominator, we can treat that as one square root over the entire thing. The square root of 48 over 150. We can now look at this fraction and reduce it. 48 and 150 are both divisible by 6. 48 divided by 6 is 8. And 150 divided by 6 is 25. Let's go back to treating these like two separate radicals. In the numerator, we have the square root of 8, and in the denominator, we have the square root of 25. Now that we've reduced that radical as a fraction, we can also reduce them as radicals. 8, you may remember, is 2 to the third power as its prime factorization. 25 is 5 squared. The 2 to the third power dividing the exponent by the index tells us 1, 2 comes out, and 1, 2 remains in the radical. In the denominator, the 5 squared comes out as a 5, and there's no radical remaining. We now have 2 root 2 over 5 for our final solution. Let's take a look at another expression where we simplify the fraction under the radical, and then simplify the radicals themselves. In this problem, you may notice that 225 and 20 are both divisible by 5. 225 divided by 5 is 45. 20 divided by 5 is 4. On the variables, you may remember that we need to subtract exponents. X to the 7th over x to the 3rd is going to be x to the 4th. When we subtract with the y's, 2 minus 8, we get negative 6. Because this is negative, we'll put the y to the 6th in the denominator. Let's now write this as two separate radicals. In the numerator, what's left is just the square root of 45, x to the 4th. In the denominator, what's left is the square root of 4, y to the 6th. We are now ready to simplify the individual radicals. Finding the prime factorizations of our numbers, 45 is 3 squared times 5 with x to the 4th. And in the denominator, 4 is 2 squared times y to the 6th. We can now simplify by dividing our exponents by the index. 3 squared comes out as 3 to the 1st. We can't simplify the 5 because there's no exponent, but x to the 4th dividing by the index of 2 gives us x squared. In the numerator, we have 3x squared, and inside the radical, we're left with a 5. In the denominator, 2 squared can come out as 2 to the 1st, and y to the 6th can come out as y cubed. With no radical left, the denominator is 2y cubed for our final solution. The quotient rule says we can treat the radical over a fraction as two separate radicals as we simplify, or as one radical over the fraction, which we can reduce. By switching back and forth, we can simplify the expression